Hello students, we all know that chemistry is a very interesting subject and today we will learn about the language of chemistry. So let's get started. Symbols. Symbols are the short form or the shorthand form of representing an element or an atom of an element. For example, we use capital O to represent oxygen, capital C to represent carbon, and capital H to represent hydrogen. You can look at the periodic table to understand how much these symbols are used. Now, let's learn about the evolution of the symbols, meaning how the symbols that we are well versed with today have evolved. In 1808, John Dalton suggested figures to represent elements, and he used figures such as these given here. He represented hydrogen in this manner: nitrogen, carbon, sulfur, phosphorus, alumina means aluminium. Soda, potash means potassium. Oxygen, copper, lead. Okay. Water. What is the formula of water? It is H2O. Okay. So H means hydrogen in this manner and oxygen. Similarly, ammonia is NH3. So N, nitrogen and hydrogen. Okay. Then came our dear Berzelius. What did he do? In 1814, he suggested the manner of representing elements, the manner that we are using today. He said we can use the first letter of the name of the element which was taken and written in capital letters. So he represented capital C for carbon, capital O for oxygen, capital N for nitrogen, capital H for hydrogen. For those elements whose first letter had already been occupied, meaning if there were two elements with this starting with the same letter, the previous element was given the first letter. So what about the rest of the elements? He said we can use the first letter from the name of the element and another letter from the name. For example, Ca for calcium, Si for silicon, Al for aluminium. And for some elements, he said we can derive the symbols from their Latin names. For example, Na for sodium, the Latin name of sodium is natrium. K for potassium, the Latin name is kalium. Similarly, for silver, we use Ag to represent it. The Latin name of silver is argentum. Valency. Valency is the number of electrons an atom can gain or lose in order to attain stability. Valency is also the combining capacity of an element. Metals have positive valency and non-metals have negative valency. Oxygen has valency too, as it needs two electrons to attain stability. So we can see this oxygen atom out here. An element needs to have 8 electrons in the outermost shell in order to attain stability. So, for oxygen, as you can count, there are 6 atoms in the outermost shell. It needs it has 6 electrons in the outermost shell. It needs 2 more electrons to attain stability, and that's the reason it has valency 2. And now, since it has to attain Since it needs 2 electrons to attain stability, it is O2 minus. How do we represent it? I'll just show you. So O2 minus. And then, for example, we can take magnesium, which needs 2 electrons to attain stability, and it is a metal. So how do we represent it? Mg2 plus. Okay, students? Now, variable valency. Variable valency is a very good phenomenon. It is a very extraordinary phenomenon which some elements have. There are some elements in nature that exhibit variable valency because the atoms of some elements can lose more electrons than what are present in their valence shell. Outermost shell is called the valence shell, and the last but one shell, meaning the second last shell, is called the penultimate shell. Now I'll explain how the phenomenon of variable valency occurs with the example of copper atom. The outermost shell of copper has 1 electron and the penultimate shell has 18 electrons, as you can see in this figure. However, the penultimate shell has not yet attained stability, and 1 or more electrons tend to jump to the last shell or the valence shell, thus increasing the valency of copper. In this chart, you can see that Cu, meaning copper, has 2 valencies, 1 plus and 2 plus. Then in a similar fashion, even hydrogen, silver, iron, platinum, all of them have variable valency. There are some more elements too. It usually occurs for metals. Radicals. Radicals are groups of elements which behave like a single unit and have a charge on the group. Meaning, two elements or two or more elements, they behave like a single unit and this single unit has a charge. So that is called a radical. For example, you can take ammonia. You can represent it as NH3 1 plus. Then we have hydroxide, OH 1 minus. Ammonia is made of two elements, nitrogen and hydrogen, and hydroxide is made of two elements, oxygen and hydrogen. I hope this session was useful. Thank you for watching.